Welcome back, everybody. Today we're going to go ahead and continue making our simple and primitive keylogger. Now, thus far we have explored the option with get async key state. That is the function that we will be using for this section anyway. But if there is enough interest and if enough people want it, we will also make one with a hook, which is a more sophisticated version of a keylogger, which is basically not scanning the keyboard, which is not scanning the keyboard input non-stop. Rather, instead, it's hook-based. It's based on hooks and it's event-driven. That is an advanced subject for which we first need to understand some of the basics that we see here. So if this works out well, then we will move into that, most likely. Anyway, before we actually get into today's tutorial, let me first remind everybody, please, that let me post a reminder, so to say, in regard to the discussion section, that I do try to answer all of the inquiries. There are about 50 of them per day. Please, if I have missed yours, if I haven't answered yours for, let's say, within 24 hours or something of a kind, please do not hesitate to send me a private message. Just send a link and I will go directly to that discussion as soon as I see it and try to do my best to help you out. What you should not do, definitely, is just send a PM stating that I didn't answer the discussion, because there are a lot of them and I won't be able to find them just from your name. That will be a little bit difficult for me. So just post a link there. It's not that hard. You just open up your discussion and copy the URL. That is literally it. And I will attend to it. Anyway, let's go ahead and jump into today's lesson. And today we will be doing a little bit of filtering with the tab, caps lock, shift, alt keys, arrow keys, and so on and so forth, mouse keys as well. And more importantly than that, I would like to introduce you today to capital, lowercase, and uppercase letters. This will be very important for us, as we do need to differentiate between the two. How do we differentiate between the two? Well, we use the state of the shift key, and we will also be able to use the state of the caps lock key. So if either of these two keys is pressed, then please write capital letters. That's what we want to tell to the program. But if they are not pressed, then please do not write capital letters, then write lowercase letters. Now, by default, it's going to write uppercase letters, so we just need to define the states for lowercase letters. That is pretty much it. First off, we have a key here. Well, not the key, sorry. I have modified the code somewhat. Don't immediately like grab your heads and oh no or whatnot. I will explain. No worries. So the things that I have changed is the name of the character in which we place our keystrokes. So I've just named it key for the sake of convenience. I have implemented this sleep function, but I have commented it out for the time being. We will use it to prevent the maxing out of CPU usage. And, well, let me put it to you this way. Sleep will pause the program for the specified amount of milliseconds. Now, you might find it strange that I have used 0 here, but okay, so 1, 2, 3, 4, 5, etc. will tell the program to sleep for X amount of seconds, or for that amount of milliseconds, sorry. And 0 will simply tell it, okay, whenever another program wants to use the CPU, you will relinquish control. Kind of convenient if you don't want it interfering with other processes, if you don't want it slowing the computer down, but this is still a patchwork, so to say, not a real solution. What else have I changed? I have commented out the switch statement, and you can see this is from my test runs. I apparently like letters R and T. I've commented it out, so we will most likely be using it further on. but for the time being I don't want to use it. I wanted to show you how you can differentiate between uppercase and lowercase letters. So you have an if statement here, and let's make this prettier because we like our code pretty and shiny and so on. Anyway, we have an if statement, and it basically says if the value of key is greater than 64 and if the value of key is lesser than 91, and if this function returns true with the shift key pressed. This is a hexadecimal notation for the shift key. I'll show you where you can get those in a moment. So if the shift key is pressed, this is basically the function that determines that. So, sorry, not if it is pressed. I have said here state no, not true. I've shown you this before. So if this function says that the shift key is pressed, and if we put the not sign in front of it, we can say basically, okay, if shift key is not pressed, please add 32 to these values. Okay, so this might not be the best of explanations that I have given you, and it might not be the clearest of explanations, but let me rectify that really quick. Let us have a look at our ASCII table. Okay, so ASCII, Assassin's Creed, ASCII table, and there we go. So the search engine is kind enough to provide it for us without having to go to any websites. So what have we stated? 64 and 91. So let's find the decimal values of 64 and 91. Come on. There we go. So it says greater than 64, not equal to 64. Therefore 64 will not be taken into consideration. And it will immediately go into 65. And we will go to 91, which is here, which 91 is also not taken into consideration because it says less than 91. And that's the letter Z, so 90. 91 is not taken into consideration. The condition states that if the user has pressed any of the letters on the keyboard, and we know this by checking their ASCII values, please check the status of the shift key. So if the shift key is not pressed, then obviously it should be a lowercase letter unless caps lock is pressed as well, but we will deal with that in a moment. Then it should be a lowercase letter, and please add the value of 32. What does the value of 32 do? Well, take a look at this. How much is 65 plus 32? It's 97. So let's take a look at the value of 97. 97 is lowercase a. Guess what? It's a lowercase of this one. And of course, if you add 32 to 66, it's just going to be 98. Yep, there we go. So B is right underneath it, and so on and so forth. So you just keep adding 32 to these numbers in order to convert them to lowercase. Simple as that. No big deal. You keep checking for the status of the shift key, and you keep on either leaving them as they are or converting them to lowercase letters. Very, very convenient. So let's go back into Windows, and we got the. Keep in mind that this statement that we have placed in here now will only record letters and nothing else, so we will need to rectify this in the foreseeable future. Basically, let's go through the statement one more time. So check whether it's a letter because letters are within this ASCII range. It says if key is greater than 64 and is lesser than 91. So this condition has to be met, this whole condition, and I'm probably better off, just for the sake of safety. I mean, I don't need to, but you know, to prevent errors later on, not a bad idea to do this, to enclose it in a separate casing. And then there's another condition: check whether it is pressed, and if it is pressed, please negate it. Check if the shift key is not pressed. If it is not pressed, then please convert the letters to lowercase. So it says key plus, I'm pretty sure that you know this by now, what this means. Plus equals basically equal. This statement is an equivalent of key equals key plus 32. And then we're going to write that to a file, and then we're going to close the file. And since we have done, during these test runs, I've simply written break here, so don't check for anything else. We might remove that later on, but we'll see how it works out. And down below it says just, okay, if the value is within this range, and if you obviously have not stated that this is true above it, then I know that shift is not pressed, so there is no need to check for anything else. Just go ahead and write it to a file. So let's go ahead and compile and see how this works. Save it. Yes, I want the empty file. Okay, so Control F11 if you remember, press enter. It's working. There we go. So let's go ahead and open up our terminal and type in, hey, do you work or not? Remember, I am typing this all together because I didn't tell the system how to handle a space or anything else, and I don't want to have any confusion now, but we will implement that shortly. And there you go. It says, hey, do you work? And then it says, or not. So you have uppercase and lowercase letters that are being recognized without any difficulties of whatsoever. So let's just go ahead and stop the program, go back and clean this file. You don't have to clean it, but I like to clean it because it's easier for you when you take a look at the new file, so that you see what the input is, so that you can make sure that it is the expected input, that it all works. Save changes, yes, thank you very much. So this would be a way to implement the differentiation between lowercase and uppercase letters. There are 100 different ways to do this. Some of them are probably better than this one. Feel free to experiment if you would like to let me, if you do experiment and whether it works out or not, I would appreciate it if you just shared with everybody else what you did, as in such a way we help to further knowledge and to help each other out. If not, it doesn't matter, but I still encourage you to do some test runs, experiment with it, and so on and so forth. So I hope that you can figure it out from this file, what I have written. I have explained every step, but if you fail to, there are always discussions, I'm always there, so just come and ask, and I will, you have 99.99% chance that I will answer in a reasonable amount of time. Anyway, I bid you all farewell until the follow-up tutorial, where we shall deal further with filtering our input.